we want to solve a complex equation, z to the power of n equal to a complex number, then we can use this particular method. Then we can rewrite this equation as z is equal to x plus iy to the power of 1 over n. Here we want to use De Moivre theorem. In order to use De Moivre theorem, we're going to do a few things. That is, let R be the modulus of this x squared plus y squared. So modulus of this particular number, complex number, and this is this. And the theta be the argument, that is the of x plus iv, or the arctangent of y over x in this case. Then we know that the fundamental theorem of algebra say if the equation has n power or is a polynomial of n degree, then it must have n results or n roots. So this can now be rewritten as z is equal to, rewritten as r cis theta plus 2 pi k, right, where k here is any number, is an integer being 0, 1, 2, all the way up to n minus 1. There will be n number of, so net n number of them. And then this is raised to the power of 1 over n. So that means applying the De Moivre theorem, this will be r to the power of 1 over n, cis, and then the argument here is multiplied by 1 over n, therefore is theta plus 2 pi k over n. For example, so z to the power of 3 equal to -8. That's -8 in terms of polar form. -8 is over here, and the angle here, the principal angle here is pi. Therefore, z cubed can be written as 8 cis in this case is pi plus 2 pi k, where k in this case can be 0, 1, or 2 because right up to n minus 1, so 3 minus 1 is 2. Therefore, z in this case is 8 cis pi plus 2 pi k raised to the power of 1/3. And so it's 8 raised to the power of 1/3 cis pi plus 2 pi k over 3 for k being 0, 1, or 2. So my answers could be, if k equal to 1, then this is 2 cis of pi over 3, or 2 cis k is going to be 1, so 3 pi, 2 pi plus pi is 3 pi over 3, or when k equal to 2 is going to be 2 here is going to be pi plus 4 pi over 3, for example. Here's a 2 in front. So my answers are 2 cis of pi over 3 or 2 cis pi, which basically is -2. So this, or 2 of cis 5 pi over 3. And if you draw this diagram up, all right, where is pi over 3? Well, pi over 3 is somewhere around 60 degrees, so it's pi over 3, 2 unit, right? So here is going to be my pi over 3, and then pi is around here, and then 5 pi over 3 is going to be here. Right, here it's going to be pi over 3 again, and each of these is 2 units. So this is a radius of 2 units. So what I get is that this will form a equilateral triangle. So notice that when this complex polynomial is equal to a real number here, that is a real number on the other side, then what you will see that here the pi over 3 and 5 pi over 3, actually these two over here are actually called the conjugate pairs. You get one complex root, then the other conjugate will also be the root to the polynomial.